Alright, in this video we're going to talk about the relay module and how we need to wire it up so that it would be able to control our motors, not just turn them on and off, but also make them go in both directions. So backwards, forwards, and left and right for the steer motor. Perhaps it is helpful to think about this with some drawings before we go too far ahead. The battery, I'll just label that as V plus where it's coming from and is trying to get back to its other side or ground. If we have a motor right in the middle and I make a connecting conductive pathway, so electricity goes in from one side of the battery to the motor and then out the other wire of the motor back to ground, that'll make the motor spin in one direction. If we want to get the motor spinning the other way, as you already saw when I tested with the 9-volt battery, we had to switch around the battery so that the current flowed through the motor the opposite way. So how do we do that without having to attach and reattach wires? Well, we can do it with two switches if we get a circuit that looks like this. So on this side will be one switch, and that connects to the motor. And we'll have the exact same thing on the other side here. So here's my switches to the left and the right of the motor. These are kind of categorized as single pin double throw switches, where this flicker right there is the single pole double throw. Think of that as the pole, and that single pole has two different throws. You can throw it up or you can throw it down. So both of these are SPDT types of switches. If we look at how the switches are set up right now and kind of follow the charge as it leaves the battery, it would come around and have this pathway connected, go through the motor in this particular way, making the motor spin one way, and it does have a complete pathway back to the batteries. Now, if we flip the switches in the opposite direction, you could do the exact same thing. Flip this down that way and that up that way. Now our charges are going to follow this pathway to get from one side of the battery to the other. And the motor would spin the opposite direction. So by flipping these two switches, we're able to get our motor running both ways. So again, we don't want to have to reach in and flip switches any more than we want to disconnect and reconnect wires. But we've got a special device that is called a relay, and a relay acts like a switch. It just happens to be controlled by electricity. So instead of a finger moving this, there's actually a tiny magnet, an electromagnet to be precise, that if we put current through that electromagnet, it will flip the switch to the other position. And things like our microcontroller, the Arduino, is able to turn that electromagnet on and off. So in this, you see it took two of these single pin double throw relays to control one motor. And if our car has two motors, one for steering and one for driving, it would take a total of 4. So with these two pairs, we're able to make both the motors on our car go both directions. Next, let's talk about what we're connecting to on the front and back of these. There's some different names that we use instead of poles and throws. The part of the switch that could get thrown up and down is labeled as the common connection on the relay, or COM. And there's kind of a default way that it's positioned when the relay is unpowered, when no current is going through the electromagnet. That's the normally closed position, or in C for short. And then the one that is normally open gets called in O. You'll oftentimes see that sometimes stamped in writing right on the circuit board in front of the connections with each relay. Notice there's 3 connections in front of each relay here, correspond to those. Or there'll be a little schematic kind of pictorial representation like what I drew here. So I can tell on this relay that the middle pin, that screw terminal in the middle, is actually my common. The right connection is the normally closed connection, and the left one is the normally open. So the exact wiring to get this all hooked up can get a little confusing if we look at it all at once, but the picture here gives a sense of what we need to connect to what, to make sure that each of the relays has a connection to the battery, we are going to put the positive voltage, like the red wire coming from our battery supply, into the normally open connection on the first relay. We use another wire to connect to the normally open on the second relay, third wire to go to the normally open on the third, and one more to get to the fourth normally open. So that creates a parallel connection, so that every single relay basically has a pathway to that positive voltage. You can see the black is doing something very similar. Those are just parallel connections of all the normally closed connections on the relays going back to the battery. In checking that against our kind of hand-drawn picture, we can see that the normally closed position had a connection to the positive, normally open had a position to the ground on this side. So that kind of checks out in that regard. What connects to the motor? Well, in the picture that I showed you there was something missing from the middle common connections, right? That was like the pole of our SPDT, or single pole double throw switch. That's where our motors will eventually get connected. Each motor has two wires, so this pair there will connect to one motor, and this pair will connect to the second. The easy way to make these connections can be using some jumper wires that you often have laying around. These work great in breadboards, but the pins on the end here are really good for these screw terminals as well. I actually already have some shorter wires that I cut and created with my solid core wire, just to make it a little cleaner, so I didn't have these jumper wires sticking out so far. These are a great way to start. Once you make sure that the wiring is correct, you can move down to putting in shorter wires like that if you want. And if you've never used a screw terminal before, they're great. You would just use the appropriate sized and shaped screwdriver to loosen the screw on the top, lefty-loosey. It opens up the little garage door on the front there. You can slide in a wire to that space. You can even do multiple wires. You'll notice that some of these have 2 wires in them. And then screw this back down. With small screws like this, you got to be careful that you don't strip out the head of the screw. So you want to make sure you're using good downward pressure on the head there, and that you don't over tighten it. So there shouldn't be a lot of strain that's on these. You just want enough that it will stay in there. Great. So my relay, like I mentioned, is already set up here and ready to go, except for its connections to the motors. So let's bring this back over here and actually get the motor connections in, and the battery as well. So finishing up with the battery first, the normally opens are all in parallel. That's my red wires. I just need to get the positive voltage from my battery pack put in to one of these normally opens as well. Now they all are actually connected to the battery. So I could do this on either end. Normally opens, I could even put it in the middle, so there's like 3. That's still going to be a parallel connection. Just to keep it clean, I'm going to put mine down at the end here. When you have more than one wire in these screw terminals, it's good to make sure they're kind of side by side, and then they get squashed flat versus being stacked on top of each other. So if you can take a little time to get that detail in, they're less likely to fall out. We'll get the battery plugged in here to the first normally closed. Tighten that in. And then we'll start getting our motors connected, remembering what pair kind of went off to each of the motors. So blue and white for me was my driving motor. I'm going to put those 2 wires in 2 relays that are next to each other. The order right now doesn't matter so much, which one goes into which COM on the relays. We can always fix that in our coding later, or with some other wires that are easier to move on our microcontroller. The thing that might happen is that we'll tell it to go forward in our programming, and it actually goes backwards because these wires are switched. But we'll see a number of ways that we can fix that. Okay, and then my last 2 wires here are my steering motors, which I'm going to put into these 2 relays common screw connections. screw terminals. Okay, there we go. So it gets very hard to keep track of stuff when you get so many wires floating around. So always remember to try to think about it with some simpler systems here, using hand-drawn notes to help plan it out, or looking back at kind of plans that just show that part of the operation. To recap here, when we're looking at the screw terminals on the front, I've got 3 connections in front of each relay. The left one is the normally open position, the middle one is the common, and the right one is the normally closed position. The normally opens, the left one, all of those are connected in parallel with my red wires here to the battery with that red wire, so the positive. All of my normally closed are connected to the other side of the battery, the negative or black wire, and then connect in parallel with 4 more wires here to jump along, or 3 more wires. Lastly, the common or middle screw terminal on each of these relays is connecting to the wires from the motor. In the next video, we'll talk about getting this relay connected to our microcontroller, our Arduino Uno that we're going to use, and actually telling these relays when they should open and close, and hopefully see this car start to move. We're also going to see a little bit of the code that makes that work the way it does in the next video.